Record. Okay, section 4.2. You really need to understand 4.1. Hopefully, you did the homework for 4.1 already. And 4.2 is an extended extension of that. 4.2 addition rule of probability. So the word mutually exclusive, we need to know this. We actually brought this up in 4.1 at the beginning. I said we're going to go to that later on and show you the Venn diagrams. You might have forgot, but there was a blank spot and says put a definition. I didn't do anything because I knew in 4.2 there's a definition. Mutually exclusive means they cannot occur at the same time. So just I would put a little note here because this is really important. You're going to see this word several times. Mutually exclusive means they cannot occur at the same time. They can't happen at the same time. No outcomes in common. Mutually exclusive cannot occur at the same time. A randomly selected female, let's see what this says. Determine if this is mutually exclusive. A random selected female student, randomly select a female student and randomly select a student his is a junior. By the way, we have to select a female student and we have to select a junior. If I pick someone, can they be female and a junior? And the answer is yes. We have junior, junior, which is the third year college. You can be female and a junior in college. So, yes, they can happen at the same time. Mutually exclusive means they cannot happen at the same time. Once again, back up here, mutually exclusive, they cannot happen at the same time. Well, if you're female, you can be a junior. So these are not mutually exclusive because they can happen at the same time. I mean, the person can be a female and they can be having a junior status. So there, this statement is not mutually exclusive because it can happen at the same time. All righty. Next statement. A person that has blood type A and randomly select a person who has blood type O. Can you have a person that has blood type A and O? You cannot have two blood types. So they are mutually exclusive. They are mutually exclusive. Mutually exclusive that means they cannot happen at the same time. You cannot have blood type A and you cannot have blood type O. So you can't have these two happen at the same time. The same person can't have both. All right. So they are mutually exclusive because it cannot happen at the same time. They're exclusive. They can't happen at the same time. Rolling a dice and getting an odd number. The odd numbers on the dice are 1, 3, and 5. Rolling a dice and getting a number less than 3. Numbers less than 3 are 1 and 2. So somebody tell me, are these mutually exclusive? Is this mic on? uh, You guys are tough, man. Come on now. Are you guys watching Oprah? What's on right now? Good Morning America. So do you see that we can happen at the same time? Mutually exclusive means they cannot happen at the same time. But if you look at both of these, you can get an odd number and a number less than three. A one could happen at the same time. So mutually exclusive means they cannot happen at the same time. So these are not mutually exclusive. These are not mutually exclusive because the one can happen at the same time. I always write sideways like this. That's weird. Okay, so rolling a dice and getting an odd number and rolling a dice getting a number less than three is not mutually exclusive because the ones are in both and they could happen at the same time. I hope everybody's getting this. Everybody's just like quiet. I should like pick on people randomly, see if you guys are even there. Randomly select a person under 21. So if you're under 21, you're between 0 and 20 years old, right? Under 21. Randomly select a person over 30. Over 30 is 31 and above. Are there any numbers that happen at the same time? No. No numbers at same time. No numbers are in common with both of these groups. So it's not mutually exclusive. Wait, mutually exclusive means it cannot happen at the same time. So it is mutually exclusive. You see, you can't be less than 20 and over 30 at the same time. So it is mutually exclusive. Mutually exclusive means they cannot happen at the same time. It is mutually exclusive because it cannot happen. Because you cannot be under 20 and over 30. You see, you can't be both at the same time. Mutually exclusive means it cannot happen at the same time. Mhm, mhm. Okay, everybody in the chat box, type in A or B. Pick a card from an ordinary deck. Get a black card and get a red card. Is this A or B? Mutually exclusive or not mutually exclusive? Type it into the chat box. I want to see how many people are actually here. 1, 2, 3, 4, 5, 6, 7. Everybody say, what should I type in? Well, everybody else is typing in B. I should type in B also. 1, 2. Oh, there you go, Jack. You picked up on that. Oh, Tanya, why'd you pick A? Mutually exclusive means it cannot happen at same time. If you pick one card, it cannot be black and it cannot be red at the same time. So it is B, mutually exclusive. If you pick a card, it cannot be black card, it can't be a black card and it can't be a red card at the same time. It could only be black or it can be red. So it is mutually exclusive. Mutually exclusive means the two situations cannot happen at the same time. All right. See, I got you guys to participate a little bit there. That's good. Selecting a song on the radio. Selecting a song in the top 40 and a pop song. Is this A or B? If I pick one song and select a song on the radio, can it be in the top 40 and can it be a pop song? And the correct answer is A. It's not mutually exclusive because it can happen. Do you see? It can be in the top 40 and top 40s can be pop songs. You see, it could happen. It's top 40 and it's a pop song. Usually, aren't all top 40s pop songs? I don't know what classifies something as a pop song. So it's not mutually exclusive. Mutually exclusive means it cannot happen at the same time. All right. So we have a formula next. When two events are mutually exclusive means they cannot happen at the same time. The probability for A or B is or means to add only when they're mutually exclusive. So we're talking about two mutually exclusive events. We're going to add the probability of A and add the probability of B. Just add them together. So this is a good example, but this formula is only for mutually exclusive. I'm actually going to go to the other formula right now and show you something. So I'm going to go all the way down here. We're going to come back up, but I want to show you the formula we just saw was mutually exclusive. If it's not mutually exclusive, the probability A or B is adding the A or B's, but subtracting one of the A and B's. So I want you to see the difference. Mutually exclusive is just this part, but if it's not mutually exclusive, you have to add it, combine in this minus P and A, and we're going to talk about that here. So there's two rules for or. We're going to add either way, but if it's not mutually exclusive, you have to subtract this, and I'm actually going to tell you why you have to subtract that here in a little bit. So we're in mutually exclusive. Now, if you look at this is the Venn diagram. It's called the Venn diagram. This is everything in A is in this circle. Everything in the probability of B is in this circle. Do you see how there's no overlap? And they're not touching. Mutually exclusive means they cannot happen at the same time. They cannot touch. They cannot, A and B cannot touch each other. Mutually exclusive means they stay separated. Okay. So that's important. And when we do mutually exclusive for A or B, we add the two probabilities together. Okay. Sounds good. So, this brings up 4.1, what we learned Monday, and we also need to use that. So, a research and development center, 3 local companies have the following number of employees. Steel has 110, Alcoa 750, Bayer 250. In a research is selected and find the probability that the employer is made by probability that they're made by U.S. Steel or Alcoa. Do you see that the or is the phrase here? When they say Alcoa, Alcoa and U.S. Steel, do you see no? All these people work for U.S. Steel. All these people work for Alcoa. Um, does anybody work for both of them, U.S. Steel and Alcoa? Do you see it doesn't tell you? They're mutually exclusive. Nobody works for both. If somebody worked for both, they'd tell you down here in another category saying, oh, 28 people worked for both. But nobody works for both. That means they're mutually exclusive. They happen independently. Nobody works for both. So the probability of U.S. Steel and plus the probability of Alcoa. Can somebody tell me what is the probability for U.S. Steel? This is a pretty good. This is a pretty good indication whether you did 4.1 homework. What's the probability for U.S. Steel? Anybody want to give me the answer? I promise you, I got to give you a quiz next time. I have to. I have to keep you awake somehow. Remember to do probabilities. We learned this last time. Probabilities of US Steel or anything equals the desired outcome divided by the total outcome. Well, the total outcome, the total number of people working is 1,110 if I add these up or add them down. If you add them, you get 1,110. And US Steel has 110 workers. That's the probability for US Steel, 110 over 1110. The probability of Alcoa is 750 over 1110. So I'm going to put this into my calculator. 110 divided by 1110 plus 750 divided by 1110. And the probability is 0.77 if I take it to two decimal places. If I take it to two decimals, whatever, I mean, the decimal places, they would tell you what to take it to. Or if they want a fraction, you just hit math fraction, and the answer is 86 over 111. So either answer is correct if they want you to decimal or they want you to fraction. Remember how to put it into a fraction on your calculator. You have to hit the math button, number one, fraction decimal, hit enter, and it changes a decimal to a fraction or a fraction to a decimal. So that is the probability that they're asking for. What's the probability that somebody works for US Steel or Alcoa? 86 over 111 or 0.77, which is 77%. Now, you can have more than one probability. If they're all mutually exclusive, you just add the probabilities up. So let's take a look at this next problem. A meteor rental store following movie titles, 162 horror films, 230 drama, mystery, romance, and comedy. So we're going to do probabilities. Let's add them all up so we find the total. So, I mean, that's kind of key. So remember, probability to find it, probability is desired on top divided by the total. So let's add up all these total. 162 plus 234 plus 114 plus 312 plus 134. 956. 956 is what I got. Anybody add those up also? Somebody better be checking my work. 312. Oh, wait, did I add the 134? 162. 134. Yeah, 956. Okay, so the desired is enter your answer as a fraction or a decimal rounded to 3 decimal places. What's the probability of horror or comedy? So we just have to add these two up. Horror is horror category. Horror is 162. And comedy was 134. So 162 plus 134, I'm going to hit enter, equals 296 divided by 956. So I get a decimal equivalent to 0.31. If I round it to 2 decimal places, it says 0.309. Since it's 5 or more, I round it to 0.31. If I put what I got on my calculator to math number 1, it changes it to a fraction, and my fraction is 74 over 239. So either one of these answers is correct for probability of horror or comedy. If I picked a rental, it's either a horror or a comedy. I have about a 31% chance. That's the probability. I know this test is in still about 2 weeks, but I'm telling you, stay vigilant. All right. So if they're not mutually exclusive, remember, mutually exclusive means they cannot occur at the same time. Do you see how the two circles touch? So these are not mutually exclusive, because if I pick a number that's right here, it's in A and it's in B. It's happening at the same time. You see, mutually exclusive means it cannot happen at the same time. This is mutually exclusive. If I pick a dot, it can't happen in both. Do you see? I can pick another dot. It can't happen in both. But if I pick a dot here, it's happening in both. So this is not mutually exclusive. If they're not mutually exclusive, we have to count all of this. Do you see how I'm counting that in there? And we have to count all of this. What happens is we're counting this part twice. We're counting it for A and we're counting it for B. So this part in not mutually exclusive, we actually count twice. We count it when we count everything in A, and we count it when we count everything in B. That's why A and B, remember, A and B is intersection, and means intersection. And we counted it twice. So we have to subtract one of them. That's why in not mutually exclusive, you have a minus A and B. Since we counted that little area twice, you have to subtract it one time. So that means we only counted it once. So this is the formula for not mutually exclusive. Okay. And I would write this formula down on my formula sheet. So in a hospital, there are 8 nurses. 8 nurses. There are 5 physicians. And oh wait, in the hospital there are 8 nurses and 5 physicians. Okay. I guess that's total. 7 nurses and 3 physicians are out of these nurses, 7 are female, and physicians 3 are female. By the way, how many nurses are male? Can somebody tell me how many nurses are male?
1.
Yeah, 1. If we have 8 nurses total, 7 are female, then 1 is a male nurse. We call them nurses. No, I'm sorry. Male nurse, nurse. Is that a derogatory name? I hope that's not. It's always fun to say that. Same way with a man purse. That's also a nurse. but we men call them satchels. Male purse. Um, Physician, 5 are physician, 3 females, so we have 2 male physicians. Okay, in the staff selected, find the probability the subject is a nurse or a male. Okay. Um, a nurse or a male, probability that they're a nurse and the probability plus the probability that they're male. Uh, can a nurse and a male happen at the same time?
Yes.
Yes, because you can be we already said that there's one male nurse. We already said that. There's one male nurse. So the probability of a nurse plus or the probability of a male. So since it can happen at the same time, we have to use the probability that you're a nurse plus the probability that you're male minus the probability that you're a nurse and a male. Do you see? This is because a nurse and a male can happen at the same time. We have to use the not mutually exclusive formula because it can happen at it can happen at the same time. We have to use the not mutually exclusive formula. So nurses, right here, there are 8 total. By the way, how many? What is the total number of people we're talking about in all of this? Total people. Anybody know how many people there are total here?
13.
13 people. 8 right here. These were the total. 13 total. And if you add up all of these, it adds up to 13 also, the individual ones. So nurses was 8. Probability that you're a nurse was 8 out of 13. Do you see the desired? Nurses is 8. Probability that you're male. Ooh, how many males are there altogether here? Anybody know how many males we have?
3.
Somebody's typing in. Yeah, it's 3. Do you see? One of them is a nurse, and 2 of them are physicians. So 3 out of 13, and then we have to subtract how many male nurses there are, and there was one of them. We calculated one of them. 1 out of 13. So when you put this into your calculator, we get 10 out of 13. 8 out of 13 plus 3 out of 13 is 11 out of 13, minus 1 out of 13 is 10 out of 13. The probability that your nurse or a male, that's the way it's called, nurse or a male, equals 10 out of 13. That's the answer for this. So, I mean, you just can't look at what you see there. You have to then calculate if there's 7 female, there has to be 1 male nurse. If there's 5 physicians, 3 of them female, there have to be 2 male. So you have to look at everything. It's best to write all the information down you can and then look at it that way. And you can change this to a decimal if you need, if they want you to. Okay. So this is kind of cool. So anytime I see a table like this, by the way, I'm not even going to read the question. I'm not going to read the question. Anytime you see a table like this and they don't have the totals, remember when we do probabilities, we always look at totals. The first thing I would do is draw a line here and draw a line here and add the totals going across. 10 plus 1 is 11. 5 plus 2 is 7. And 17 plus 3 is 20. When you now add them going down, I get 38. So we're talking about 38 people. I'm also going to do this just to verify. Well, not just to verify, but I always do this. Add these going down. How many doctors? These are MDs. MDs 15 and 17 is 32. And when you add these, you get 6. Do you see 32 plus 6 also equals 38? So you're going to add them, add everything going across and add everything going down, and you should end up with the same number. There are 38 people we're talking about here. 38 different people we're talking about here. So let's, oh, I should have scrolled down a little bit more first. Let's see what the question says. Find the probability, if you choose one doctor at random, find the probability that they're an orthopedist. Oh no. Um, orthopedist. Which one? We have doctors of osteopath. Okay, osteopathy. Orthopedist is orthopedic, same thing, I guess. Um, somebody said something, but they typed in 3. What did we type in 3? Oh, be careful. Let's look at this again. Choose one doctor at random. Find the probability of the following. Express an answer as a fraction or decimal. That she is an orthopedist. How many orthopedists are there? By the way, I think this orthopedics is an orthopedist. How many orthopedics are there? There are 20 total. Do you see? This is the total. Orthopedics are 17 are MDs, 3 are doctors of osteopathy, but there are 20 orthopedics or orthopedists. So there are 20 out of 38. So the whatever that divides by 2, and you get 10 out of 19. The probability that she is an orthopedist is 10 out of 19. Okay, that's the first one. Does everybody see that? Do you say orthopedist and orthopedics is the same thing? And there's 20 of them altogether. 20 out of 38. All right, so I'm going to go to the next. Let me erase that answer. That's 10 out of 38, or 10 out of 19. I'm sorry, it reduced. Number 2, he is a pediatrician or an MD. Pediatrician or an MD. Pediatrician or an MD. Okay. So pediatricians are how many probability of pediatrician or MD? By the way, my question to you is, can pediatricians and MDs happen at the same time? Can you be a pediatrician and an MD at the same time? Yes or no? And I'm hoping you said yes. Yes. Do you see, right? See, these people right here are all MDs. These people are pediatricians. These people are pediatricians and MDs at the same time. So since they can happen at the same time, you have to use the not mutually exclusive formula. Not mutually exclusive formula. Probability of pediatrician, or which is plus the probability of MD, minus the probability of pediatrician and MD. Probability of pediatrician, there's 7 of them. 7 out of 38. MDs, if you go down, there are 32 MDs. 32 out of 38. Do you see 7 and 32 already add up to 39? Adds up to more than what we have. We only have 38 people. But it's because we counted, do you see we counted these going down, we counted this 5. And when we went across, we counted this 5 again. Those 5 people got counted twice. That's why for not mutually exclusive, that's why you have to subtract one of them. So I'm subtracting the pediatrician and MD. I counted the 5 this way. I counted the 5 this way. I have to subtract one of those 5 out of 38. The pediatrician and MD. Do you see? They are a this is really important. Pediatrician and MD right here. 5 of them are both. 5 of them are both. That's why you subtract that. So 7 over 38 plus 32 over 38 is 39 minus 5. So the final answer here, 39 minus 5. I'm gonna put the answer if it lets me write it. Is 39 minus 5 is 34 over 38, which is 17 over 19. Probability that your pediatrician or an MD is 17 over 19. 7 over 38 plus 32 over 38 minus 5 over 38, because we counted that 5 twice, equals 34 over 38. By the way, you can't have more than 38. You know, when we added the first two, we had 39. It's because we counted it twice. We counted these twice. We counted this way for 7, and then down for 32. We counted that number twice. We had to subtract it once. Okay. I hope there's no question 3 on that. Yeah. Okay. So here's the next one. You see on this one, they added all the totals for us already. Thank you. Thank you. Thank you. So this is let's take a look at this one. Choose one species at random. Find the probability that they're threatened, a threatened species, and they're in the United States. And means it happens at the same time. So threatened is over here. Do you see? This side is threatened. Threatened in the United States. So how many are threatened in the United States? And by the way, we would write it like this: the probability of threatened and in the United States. So can somebody tell me how many are threatened and in the United States? Anybody? Type it in. Threatened and in the United States. And the answer is 62. Thank you, Chima. Do you see right here where this side is threatened? This is the United States side, and there's 62. So it's 62 over the total, which is 802. You see, if you add these up, you get 802. If you add these going across, you get 802. So threatened in the United States is 62 over 802. You put that in your calculator and reduce it. 62 divided by 802. 0.077306, but if you hit math number 1, it changes it to a fraction, 31 over 401. Okay, so let's go on to the next one. Stop me if you have any questions. You guys are all asleep, I know that. Thank you. The person is awake. I really should have some kind of a quiz. I really should. 0.077. So I showed you that's what I got when I put it in my calculator. What was the B? Oh, an endangered foreign bird. What is the probability that they're an endangered foreign bird? So endangered on this side, and a foreign bird. Look at that. Endangered on this side. This side is foreign. This side is bird. Do you see? An endangered foreign bird, there's 184 of them out of 802. Out of total of 802. And so whatever this equals on my calculator, they want it in decimal. So I'm going to do 184 divided by 802. And I get 0.22. That doesn't sound right, but I guess it is. Let's see what did they get that answer? 0.229. Yep, that's what I got. 0.2. Everybody see how we got that? Endangered and foreign bird. There's 184 of them. On the endangered side, bird 184 out of a total of 802 animals that we're talking about, or whatever creatures. A mammal or a threatened foreign species. Okay, so let's do C. A mammal or a threatened foreign species. So if you look, here's the mammals. These are threatened foreign species. Do you see how something we added twice? If I add all across the top, I get probability of a mammal plus the probability of a threatened foreign species. But since they're not mutually exclusive, we counted the number 23. Do you see, to count mammals, you have to add all of these up, and it equals this. To count foreign species, you have to add all of these up, and this is what we got. We counted this 23 twice. So since we counted it twice, you have to subtract once again, mammal and threatened foreign species. So mammals was 362. There's mammals, 362. Foreign species was whatever that threatened foreign species is, 49. I just wanted to see that. Okay. But we counted the 23 twice. So you have to subtract the mammals and threatened foreign species. And 362 plus 4. Wait, 49, not 4. There's 49 down here. I just didn't write it. There's 49 down there. 362 plus 49 minus the one we counted twice, minus 23. And I get, I don't know what I get, 362 plus 49 minus 23. I get a total of 388 out of the 802, out of the overall total. And when I put that in my calculator, divide it by 802 and round it to 3 decimal places, I get 0.48. Just 0.484. If I round it to 3 decimal places, 0.4837, which is 484. 0.484. So C is what I got, 0.484. That's what they got. And luckily, that is the end. That is the end of section 4.2. Any